Hello everyone, my name is Jasni. I am here to present my research topic, that is a cost-effective integrated water management considering climatic conditions. As we all know, water is an inevitable part that is essential to survive in this world. Although Earth is the only planet having large water resources, the fresh water is accounted for only 3% on Earth's surface. The water demand is increasing tremendously following industrialization and rapid rise in population. Moreover, water management has become inefficient due to unprecedented climate changes. Hence, an effective technology that can mitigate all these issues is the need of the hour. Here comes the importance of integrated urban water management. Integrated urban water management is the combined use of all water resources, which includes rainwater, sewage water, drainage water, etc., and optimal allocation of all this collected water according to the water demand without affecting the ecosystem balance. Various studies are progressing in this field to find out the efficient water management process. Now let's discuss about the existing water management process. These are categorized as different management models and different approaches. The first one is GIS-based model. The introduction of GIS was a milestone in the management process that can reduce the complexity in research. GIS was a modern platform which records instantaneous changes in geography, and also it can provide real-time solutions. A study was conducted in China to evaluate the efficiency of Spawn City, and its efficiency was evaluated with GIS-based index, and it was successful. The results of this model can be easily simulated with the help of ArcGIS software. Even though the study was successful, from the social perspective, it is not effective in private perspective. Hence, another study was done to find out the groundwater quality in tourist destinations. Here, a TGH index was proposed, and the proposed index revealed the direct relationship between groundwater contamination and tourism activities. There are some limitations in this study. The study mainly focused on small databases. These are the results obtained from the GIS software. The first figure indicates most contaminated location in the study area. It also represents the groundwater flow directions. The second figure indicates various TGH indexes. The whole area is categorized according to various levels of contamination. Next one is ecological footprint model. The impacts of various factors can be estimated with a single mathematical expression. A study was done in China to monitor the consumption and the water supply in urban area. The study was successful in indicating the influence of urbanization and industrialization in city. However, the future prediction and multi-scenario approach was not possible in this model. Next one is a different management approaches. It was carried out by considering various factors. The first factor is rainwater. It's a traditional approach in which a communal rainwater harvesting system was designed during in the year 2013, and its design includes the collection of rooftop water of residents from 46 residents, and the water was stored in a common tank for water treatment. After water treatment, these stored water is reallocated to different residents according to the water need. This system was successful, but the energy consumption was more in this study. The next one is wastewater. A decentralized system was designed to remotely control wastewater. Uh, However, this study was failed to consider social factors. The next one is a clustering method. It's a modified decentralized method system. Even though the system was successful, this cannot be applied with the complete water balance model. The next one is institutionalization. Deeper institutionalization facilitates improvements in water management. The last one is distribution system. The introduction of artificial intelligence influences water management system. Here in this study, microcontrollers were introduced to monitor the water losses in pipelines. The next one is, and most factor is climate change. It is crucial because our world is vulnerable to vagaries of climate change. Hence, an efficient technology that can accommodate all the climate changes is essential. Various studies are going on in this field, and these are some of designs and technologies which includes climatic factors, and these technologies also include some limitations. Some of the technologies were completely based on analytical approach, and some of them were based on statistical approach, and these studies were not efficient efficient and not economical. So after this detailed research, I have reached one research question, that is to select a cost-effective water management method that can accommodate various climatic conditions. To solve this question, I have selected two papers and analyzed working technology of different working technologies in two different papers. The first one was based on analytical approach, in which real options and fixed adaptation measures were introduced with the help of different models, and these real options and adaptation measures were compared. After that, a flood risk assessment was carried out with Caldi's model, which was followed by cost analysis. At the same time, the second paper was purely based on statistical approach. A stability index to evaluate the impact of several climatic factors were introduced in the study. Moreover, RRV indicators, that is resilience, reliability, vulnerability of different indicators, were identified by using different probability distribution methods. Finally, a geostatistical modeling is also obtained in this study. By combining all these technologies, I have proposed a new design. These are the design process. The design was initiated with selection of location that is more vulnerable, that is most contaminated area in Australia. In Australia was identified with the use of ArcGIS software. After that, hydrological data were collected from meteorological observatory. The data includes precipitation rate, evaporation rate, temperature, etc. By considering all this data, a probabilistic approach was proposed to identify most important one that can impact water management. After this study, the results were revealed that rainfall intensity has more influence in water management. The next step was mode flow models. Mode flow models are the three-dimensional representation of the study area. It can represent groundwater flow as well as surface water flow, through which water-logged areas can be identified. By combining all these results, the actual water that can be supplied for residential purpose is calculated. And finally, the economic feasibility of the study was identified by using cost-benefit analysis. These are the design process. And next, coming to the solutions, an efficient water management can be identified by using this design process, and an optimal water allocation was possible with the study. The fluctuation of climatic change is introduced in urban water management. The study involves numerous procedures and parameters, hence sometimes the study may be difficult in the case of large area. It's all about my design and research. Thank you.